I have a couple more examples here where we have some prefixes, and then we're going to give our final answer in standard SI units. So for the first one, we need to look at the resistance of a component. So we're going to use the equation that says R is equal to V over I, the potential difference across it divided by the current through it. So that's going to be equal to 20 times 10 to the minus 3 volts divided by 12.5 times 10 to the minus 6. And because we've got minus 3 divided by minus 6, this is going to give us an answer in the region of 10 to the 3, so something in the thousands. So if I do that on the calculator, we've got 20 times 10 to the minus 3 divided by 12.5 times 10 to the minus 6, which is equal to 1600, and the units for that would be ohms. So the kind of thing we're expecting when we're dividing a small number by a really, really small number. For the next one, we've been given the density, we need to calculate the density of a 26 gram pebble with a volume of 10 centimetres cubed. Now we're going to be using the standard SI unit, so we're going to be using kilograms and metres, not grams and centimetres. So the density is equal to the mass divided by the volume, and the mass is 26 grams. But here is another kind of quirk that we have with A-level physics. The standard SI unit for mass is a kilogram, so a gram isn't actually the standard SI unit. In order to actually work out what this is in kilograms, that would be 26 times 10 to the minus 3 kilograms. And we're going to divide that by the volume. So the volume is 10 centimetres cubed, but of course 1 centimetre cubed is the same as 1 times 10 to the minus 6 metres cubed. So if we've got 10 centimetres, that's going to be 10 times 10 to the minus 6 cubic metres. So when we work that out, so that's 26 times 10 to the minus 3 divided by 10 to the minus 6, which is equal to 2,600. So 2,600 kilograms per cubic metre, which sounds about right. Imagine you've got a cubic metre of stone. It's probably going to weigh about 2.6 tonnes. So I think that's an appropriate answer there. So I've done this just by identifying what the prefixes are, and then when I've come to actually write out my equation and put the numbers in, that's when I've converted from the prefix into our standard SI units. By the way, this is just one of many videos I've made covering all of the maths that you need to understand for A-level physics. It's part of the mini course, which includes many more topic videos, multiple worked examples, and also a guide that you can download. You can find all of this over at alevelphysicsonline.com.